Okay, so we can go to Gen file that's open. Yeah. Close this. You want to just start from the manual mode or experiment mode? How do you want to just start something from scratch? Maybe?
Yeah.
Okay. So the manual mode is this microscope icon right there. And then this is, we don't want to use the 40x, maybe like 10, 20 is good. Okay. And this is not the Agilent plate, so click on that. I think this is the CoStar copy, the second one.
Yeah.
Yeah.
The
Okay.
tech support you mentioned I had to call them one time because I was having autofocus issues and help
Oh.
solve it.
Yeah, the bottom animation part.
Yeah.
Yeah, I'll also walk you guys through that actually. It's very important.
Yeah, something important that you have.
Right? So always hit auto expose and auto focus. Perfect, just like you did. Okay. So in case you use another plate type, that's not this, and you want to set it up into the software, there are a couple of ways to update the plate type. So either you can update the same plate type that exists in the software, you can also create a copy of the plate type. So for now, because we are already in this plate, I don't want to go back and show that other option to you, but remind me once we are done with this, I can show that to you. If you go to focus, and you see there is update versus bottom elevation. This is basically to set this bottom elevation, which is this value, which actually is used to find the focal plane. So if this value is not close to your cell size, so maybe if you go like coarse focus maybe 4 or 5 times, maybe more, yeah. Yeah, something like this, right? And then if you try to auto focus, it may or may not work because this is too far away from where your cells are. So if that happens, and if you see this value is very different from where your cells are, you just click on this button, which will update the vessel's bottom elevation. We don't want to do that for this plate because it's gonna mess up all the protocols we has. So that's the other point. You never want to update something that is already existing. You always create a new one. Let me just actually take you there. So just close it out.
Okay.
So I can show that. Close this task manager. Go to system.
Yes.
About that. Yep. And plate types. And let's just click on favorite on the top left. So you have all these favorited plates which are frequently used. So let's just try to create a copy of the copy plate. Just copy it again and just name it like test or something. So you can then delete it. Yeah, and then imaging parameters, and then set it. I'm just gonna set it up to 1000. Right? Click OK, and let's go back to the manual mode now. And we'll select the test plate.
Oh, we
So-
did not select.
Yep, it's okay. So we'll carry it out. I don't think it will allow you to change it. So close it and restart this.
Sorry. I
No
just
worries.
remembered.
No worries. You can also do it from here. I didn't want to interrupt because once you do it one time, then you would remember it for the rest of it. So it's always good practice to test it out. Test and then. Yep, and now if you're using this plate type for autofocus, you can see how that's not gonna work, right? So now we have to basically use either the autofocus option or the coarse focus option to first find where the cells are located. And see, it's like just failing because it's too far away from it. So now we click OK and just find this coarse focus option and go up from there.
Coarse focus.
This one, yeah. You go up until you see something. it's in like 3500 range. And you can also type it in. You can
Yeah.
click on these three dots and just type in like 3500 for now. Apply and close.
Go down from there.
Yep, and then close this
Oh, close.
and autofocus now. Autofocus should go.
Oh, goodness.
So as long as you are kind of close to
Seeing
it,
something.
yeah, should be okay afterwards. Because the exposure is too high. It's okay. So we can just do it manually.
Going down.
It's on the other side. Yeah. Alright, so now hit auto expose and auto focus. And now you see this area is bleached.
Yeah.
Yeah.
It's okay. Go to focus.
I can get a different plate too.
Oh, it's totally fine. And then update the vessel bottom animation and click OK. So now this is part of your plate type. So now when you try to autofocus, it's not gonna fail.
Gotcha.
Otherwise it will fail. Yeah. Alright, so just to give you a recap, do you just want to try taking images in multiple channels and make it kinetic for the manual mode? Yeah. So let's go to maybe a different well, like B2 or something. Sure. Again, just hit autofocus now because the exposure is already set. One time auto expose and then autofocus. Yep. And then since we have a little bit of time in our hands, I want to show you or explain you like what this histogram is.
Mhm.
So if you see the histogram is kind of spread out evenly, which is nice, which is great. If you boost up the exposure, like just click on this plus icon maybe 5 times or something. You can see it's kind of going up on this side, right?
Mhm.
But it's not significant. So maybe minimize the focus tab and increase, populate the exposure tab, please. And boost up the gain all the way up. Yeah. So now we can see this is completely like this is a plateau on the right side. This the black band, which means that these pixels are saturated. But sometimes if the room is like very lit, like there's a lot of natural light coming, you won't be able to gauge that, right, from this image. So you can also click on this show saturated pixels,
Yeah.
which will show you everything that is saturated, which is basically everything here, right? So you just click on auto expose and kind of see it go away completely, right? So this is what you want. You want to be in a perfect good dynamic range so that you capture all the intensities. Yeah. All right. So now we are happy with this, so we can click OK and capture, and then let's just take one image in bright field or GFP. Either of those two is fine. And I think the exposure looks good, but you can change that if you want, and you can also focus it if you want, but I think it looks good for now.
I think it's fine.
Yeah, just capture it. Right, so if you then go to the imaging mode option, which is the third, Right now we see one box which is kinetic imaging. So you can even do kinetic imaging within the manual mode if you're interested. So click on that and then edit imaging step. So now you see the same loop that we had seen earlier. It's the same exact thing. There is also a fast option and a slow option. Fast is for like anything that is milliseconds. Everything in minutes is going to be slow kinetic. So what you want is kind of slow kinetic. You want more than 30 minutes, right? And then you just define it here. So the interval and the total time and everything. And the last one is seconds. The second one is minutes. That's hour.
Oh, shit.
Yep.
Right?
Yeah, and then it's set every second for now. So maybe we can change it to like every 30 seconds for now.
30 seconds.
Yeah. Just to make it fast for the practice. And then just set it to maybe like 3 minutes.
Yeah, that's
something.
excessive.
Yeah, for now, yeah. And then click OK. And one more time, click OK. And then just capture this.
Oh, really? So that it's good?
So within every 30 seconds, I want it to start moving to the next well.
It will.
Okay.
Yeah. When you set it in an experiment fashion, it will. Right now,
Yeah,
because I
okay.
said right now, imager manual mode is limited to one well only.
Right, exactly. Okay. But I'm just training it to do it this way.
Exactly.
And
Yeah.
then the experiment
Would contain all the information. Yes, you can even convert the read if you want, and then you can right click, create experiment that should retain all the information. Yeah.
Gotcha.
And then just add multiple ones.
Okay.
Crazy.
Oh, and it gives you a countdown too.
Mm-hmm.
Should I abort?
Let's take a couple more images and then.
Yeah.
Because I also want to show you how that video would look like and how you
Mhm.
can access those images. Maybe let's let it go through the third start. Okay, we can abort it now.
Next week, probably.
It's gonna think about
To
it.
get whatever shit.
Okay, so now if you go to the time lapse, which is the next one, you should see all the read steps. So there's one, if you click on, yeah, that's 2 and 3. Everything is static, right? So it's not moving.
Mhm.
But this is how you'll see it. And then if it's a long-term experiment, like a long-term kinetic, you can also click on this kinetic frame alignment, which will align all the frames together.
Okay.
So for example, you put in the plate today and then come back tomorrow, put in the plate, it's gonna try to match this cell, like wherever that is, and it's just gonna fit it within the frame, so it's gonna look seamless.
Okay, that's
That's
awesome.
really
Yeah.
good. Yeah. And it's just by default. You just click on it and that's it. Yep, that's it. This is how you align it. And then if you want to save this video for now, you can just click on this record button, which is next to it. And this will save your video. And then I always look, I don't know why this is set in like smaller file size. You always want to use the highest image quality. So I use that, and this is the frame rates, and you start saving.
We have 2 copies of the Gen 5 program.
Yeah, we
Oh, it's pretty fast, right?
Yeah.
I'm not sure if we have it.
Okay, that's good.
Yeah.
And then I
And then-
save the experiment.
Yeah. And I right click, create experiment.
Oh, shit.
Yes.
Well, I don't know if you-
So what it asked you was you want to use a well mode. Well mode will finish one well and move on to the next well. I just wanted to show you how this looks like in case there was something that's very dynamic, that's very fast. Then it's gonna finish up one well and then go to the next well. You can still define all the wells, but that's not what you wanted. So we can just use this kinetic interval. So I mean, at this point we'll have to delete it and restart it. So reset it. So just right click on the well mode. Or actually, can you click on the kinetic and copy it? Right click and copy and paste it under the well mode.
Also,
Yeah.
there's Shinewani.
Yeah, and then delete the well mode entirely. Right click and remove. Yep. Right, so this is your protocol, and now you would set the wells here. So if you go to the 10x, we would select instead of the full plate, the wells you want to select from there.
Mhm.
And then if you want to use a manual focus or like a laser autofocus, then we'll select that. So typically you would select like laser autofocus because those would be at different Z heights.
Mhm.
So let's just try that for now. Instead of full plate, clear all. Just select the whole B row. Yep, click OK. And focus options. We don't want to use the default option, so click on uncheck the default option, and we'll set up the laser autofocus. And yes.
You don't know how it
Okay.
goes.
This is just asking you to train the software where you want to focus on.
Okay.
So we are doing B row imaging, so let's go to B1. And then once it looks kind of in focus, you just set up that offset. So if you think this is good, then you can save it. If you don't think it, then you just use your autofocus option to focus on it. And then you would just save it. And for bright field, the focus that software thinks is good may not look good to you, so you can change that obviously if you want. And then once you're happy with that, just save settings.
So for the kinetic readings, can you see a trace from an individual cell in terms of whatever metric you're measuring from it, like
Yeah.
how it changes over time?
Yep. So there is also a cell tracking module that's an add-on for
Okay.
that. But you still get like the cell level, object level details, but that's not going to be aligned. Like if there's like cell number 1 in one image, that may not be a cell number 1 in the other one.
Oh, okay.
But if you buy the tracking module, then it will keep track of that. They're like separate modules. Okay, and then click OK. And click OK. So now you're set up, you know, the wells we want to
Yeah,
image.
yeah.
We have set up the interval time, and now we can click OK.
Individual cell
And
metrics. I don't know if we
click.
need that because
And you can,
I don't know the stuff necessarily. Like at the cyber kinetic experiment where you just over time again you just stick in the same place once an hour.
And then you put maybe LPS and see if they go round, and then you can put PHP or whatever,
Yeah.
and see if they go back to the opposite.
Yeah, you just do it times 10 data versus you just take in the same cross section of it.
So within the 30 seconds, it's switching the wells? Or
no,
am I
it's
just
30 seconds for the first time point, and then second time point should be collected at like 31 seconds.
Okay.
Make sense? Yeah, so it should be able to finish the whole row in 30 seconds, and then it's going to go back to V1.
Okay. That's what I need.
Yeah, yeah, yeah. And if that's going longer than 30 seconds, then it will display fields. If you go to different time points, it will also give you timestamps.
It would show me down here.
Yeah, so if you now if the second,
That's a good point.
so now it's going to go to the second read. So if you go to the second read, right now it says variable, but once you export it, it will have the timestamps.
Oh, okay.
And you can also click on this image and view metadata, and this will tell you like the system date and time. So this is 5132, right?
Yeah.
And if I go back to this one, 06. Okay, it's actually a little less than that.
Yeah.
You got Western Love?
Okay. That's good.
Pretty good, right? Yeah.
That's all I need.
Yeah, and once this finishes the third read, we'll just abort it, and I'll help you align those images so you know how that works. Pretty straightforward, right?
Mm-hmm. Well, now it is.
Yeah.
It's funny, he records also some little movie about what happened.
Mhm,
Right?
mhm.
That's
So
cool.
you got what you wanted, Francisco?
Hmm?
You were able to do what you want to do?
Mhm. I didn't know that we needed to set up an experiment to do every well, because that's what I was having issues with.
Thank you so much.
Me neither when I was a grad student.
But it makes sense. It's,
Yeah.
You're supposed to test it out and then create the protocol.
You guys are in a very good situation where you are able to have someone come in and teach you how to use the software. I had to basically learn everything myself, and definitely made a lot of mistakes there. So you see the alignment is already applied, and this is with the alignment. You can still see some cells moving. You see,
Yeah.
I don't know if they're floating. I think they're floating. Yeah, I think seems like they're floating.
did
Some of
that.
them are floating, but you can also see. Yeah. This is with the alignment, and this is the without alignment. So you can see like the images might shift a little bit in terms of its x and y location, you see, but then you can set the alignment
It's cool to see you.
and you can play it also.
Wait again?
Yeah.
Look at that top, just got crumpled up.
That's so sweet.
Oh my God, that's so fun.
Oh, wait, that's only over a couple minutes?
Just 2 minutes.
Wow, they move pretty quick.
They might be floating too.
We don't know.
We have to look at the calcine to see alignment there.
No, I think they're.
They should be, yeah. I mean, looks like they're
Oh,
not
yeah,
dead.
actually, these plate types, they. Yeah. all my assays on these plate types, they really, even if you kill them, they're still attached to the plate kind of
Okay.
weirdly.
Okay.
Yeah.
It's pretty good. Yeah. Nice. Yeah, you can definitely see a lot of movement there. Yeah. Yeah.
Yeah, those little walled up ones might be them.
Yeah. I see the ones I'm talking about.
Yeah.
Like the warp.
The ones that are kind of like
The
really
warm
walled up,
one?
irregular
Well,
shape
the
might
worm's
be dead.
probably debris, but the circular
I
ones
don't know what that is. I think that's some
might
debris.
be
But
just
yeah, super
dead
cool.
and floating around.
Oh, no, what am I talking about?
Yeah, running.
What was the cell type?
EV2 microglia. That's what they're very movement.
Mhm.
Cool.
Yeah.
Nice.
By design, they're supposed to move.
That's kind of their whole thing.
Yeah.
So there's one more thing. That one is literally the last thing from my end. I want to show you guys. So if someone wants to take control, then I can walk you through it.
Or she need to worry about it.
Oh, okay. Whatever.
I mean, okay.
Or progression.
Got this.
Yeah.
So I just want you guys to like know what the beacons are, like how you can apply the image stitching and everything. So I'm just gonna show you all the options that exist. So you can close this experiment, and do you want to save the changes? Yeah, right. Just save this for reference.
I think we did already, right?
Yeah. So now we applied some alignment. So we have to kind of, whenever you see this asterisk on top,
Mm-hmm.
that means that it's not in
It's
save
not
state.
It's not saved.
So if you save it,
So I go to file.
yeah, and then save. You can click cancel for now. We just want to save the same file, so just click
Yeah.
save, and that should then go away.
Okay.
But, and you can go to file and then close.
Yes. Oh, okay, close.
You want to save a protocol. Most likely we don't want to save this protocol, but in case you build something, then it will actually prompt you before you quit the program.
Mhm.
Actually, do you want to save protocol or not? In case you forget that, you can always go back to the experiment and then extract the protocol from there.
Oh, yeah.
So you're not gonna miss out on that,
Okay.
right? So if you go back to the capture step, click OK. Thanks. Just focus it manually. What do you think would work the best? So this is the course focus. Yeah. And the bottom one is course. And the next to it is the file focus. So of course is fine. Right. So what if you wanted to stitch the images within this manual mode? You know, you don't want to go to the experiment mode and stitch it over there. You also can do it within the manual mode. I really like the option to do it in the experiment mode because you can customize that. If you minimize this window for focus and go to imaging mode, which is the fourth, you still have that option here. So you see the kinetic imaging is turned on. Check it off for now and click on montage. So here now you can select the boundaries. So if you go a little bit one step up, maybe one step up, set the top from there and go to the bottom a little bit, maybe like couple steps below, and then set bottom. And then just do the same for left and right.
Yeah, I don't know if it was because we were still on the old software,
Uh-huh.
but we tried to do a montage once and it just it was stitching in the wrong areas. So it was all chopped up.
I
Okay.
remember before I was referring to the.
And we did it long and it was like several.
I've seen that happen once,
Mhm.
and it was also because I was trying. It was like another instance of Gen 5 was open on that day, and I noted like if something is open, then it just completely destroys your stitching algorithm for some reason. So we check that first, and if that still happens, just email me.
Yeah, definitely nothing else was open at the time.
Okay.
But we've never tried it on the new software,
Yeah.
so
Yeah, it should be
it
okay.
might have been something about how it is not
Mhm.
moving at the same rates and stuff.
And you see there is an overlapped
Yeah.
region, and that's on purpose. So now it will like retain this information, and this information it will match it, and then it will be able to stitch it. So to stitch this image, you have this stitching option there, and just click OK. and this is the station.
Yeah, we wanted the long slide.
So this is
They
the
wanted
bigger picture of the
bunch
wall,
of it, yeah.
right?
Yeah, it takes 10% overlap by default because it needs some
Yeah,
information to
yeah,
match
to like-
and then stitch.
One composite.
So,
Yeah, the whole slice.
so the default options work really nice for the most part. Yeah, so that's how you do stitching. And then if you right click on this and create experiment,
Alter it all, so you can smart it out as well.
double click on this in 10x. So now if you wanted to then do a Z-stack within the same montage, you still can able to. You are able to do that as well. So just turn on the Z-stack. How many slices do you want? You know, and you can just set it up. You can also set up your focus point. So if you want to start from the bottom and then go up from there, you have that ability. But we are already auto-focusing. So
Okay.
for that, you would actually shift this focus step to like somewhere in the center. Yeah. So now you're gonna focus, take 5 images below that and 4 images above that. So it's a pretty
It's
good
like a
comprehensive.
3D image.
Yeah, if you have some 3D sample, then you can do that.
So I didn't get like what the role of this one. So if,
Yeah.
if you start on the top, what does it come from?
Yeah, so we started from like a, you know, it's first going to use autofocus. So it's gonna
At
focus
this point.
some bright field image. That is your focusing point.
Oh, okay.
And then it's going to collect, you know, if it's number 6, then it's going to collect 4 more
Okay.
images. Like, you know, this is like, imagine this is a 0 micron, that's going to take 1 image, 10 micron, 20,
Okay.
30, 40, and so on
And
on
then
the
6
bottom side.
below.
Yeah,
Okay.
yeah. So click OK, and then at runtime, just run it at runtime.
Oh yeah, can you just explain me back again these
Yeah.
first step
Yeah.
and runtime?
So per step, go back to that, double click on the imaging step. You have to define it here. So if full plate is selected, and if you run it per step, then it means that in this step you have selected all the plate to be imaged.
Okay.
But you know, if those conditions or those values are going to be variable, my go-to way is to run it at runtime. So let me show you that. So click OK at runtime. Click OK. Yes. Because we have also applied Z-stack now, it knows something has changed. You know. So either we can stitch it first or we can do a Z projection first, either one is fine. You can just double click on it and it just wants you to check that something is different, but that's okay. So we can click OK, click OK and start this experiment. Yeah. So now it will actually populate which vase do you want to image. So this is the difference.
So if you select first step, it's just gonna
It's gonna image all.
image all. And we cannot. There's
I
no way
mean,
to select
in that step, you have to go back and then change the amount of values in the image. But this is gonna be very variable each time. So if you have some changing conditions, then this is useful. Maybe just select 1 or 2 values for now. Yeah, and okay.
Just gonna save it as just.
Okay. And you will see this will take a lot longer because now we are doing 40 images per hour.
Jeez.
40.
40. Because we are
Okay, so
taking
it's
kind
four,
of a Z-stack
yeah.
for 4 different images.
So you're doing Z-stack and a montage at the same time.
Yeah, so it's gonna, yeah. So you see now it's doing the Z-stack. It's gonna go to the third image,
Yeah.
focus it, and then,
Basically 40 images per well.
per well. Okay, in the meantime, do you guys have any questions?
And you were talking about the
Vibration table?
The vibration
Yeah.
table.
It does seem like yours is a little bit on the older side. So if you see here, there's an indicator. When you get it, it's like absolutely green, and then when it sinks, it starts turning red. And then when it's completely red, at that time you have to replace it. So yours is kind of
It's a little
still not completely red. I mean,
Yeah,
it's
because
a
it
little
looks
bit.
completely to me.
Okay.
Do you see-
I mean,
do you
you
see-
have you have to
see
see it
red,
from the
yeah.
ground level. So I don't
Yeah,
know.
Put your face like on the counter.
Yeah.
Hard to tell.
I mean, it does seem red, but not. I mean, I see a little green, so.
Yeah,
Just a
exactly.
little
So
bit.
if you see
Yeah.
some green, then it could be still okay. Yeah, I took an image. It looks red in the image though.
Yeah, exactly. When you
So-
look at it this way, it looks like red.
Yeah,
for
so
you.
when you start seeing some issues like vibration issues or focusing issues, you have to replace them. For now, it's okay.
Okay.
You're not doing like 60x imaging very often, so it's fine. But when you do, you have to replace it. So now double click on any of your images. And by default, it doesn't display the true resolution. You have to click on auto load images to load them up.
Do you know how much the vibration table costs? The biotech one?
You ask me all the sales questions. I don't. I don't.
You're here.
Yeah, I know. Click on bright field and then stitched.
$1, $1 million.
So now it's a stitched image, and if
Yeah.
you go through the different Z heights,
Oh.
it will show different Z heights like that.
So we can do this with like the other channels as well.
Yeah, you can do it in multi-channel imaging. So. And then when you want to project that, you click on process and click on a new analysis step. So I want to set up a new step and then Z projection. Click OK and one more time. OK. And this is the Z projection.
So this is the image captured at 10 level. But there's a way to see like in 3D actually? Or
I mean, for this 2D flat audiences, not really, but when you have actually a spheroid or organoid, then you would be able to see somewhat a 3D viewer. There's also a 3D viewer that we have, which will allow you to do that. Let me see if that is here. Yeah, so not here, but this guy. Yeah, not for bright field. It has to be fluorescence. So not for bright field. So
can we
you-
try it?
Sure. It's not gonna look pretty or anything. I can
Okay.
show that. No. Alright, you can take control.
Can I try it?
Yeah,
Sure.
sure.
I can give you this chair.
There's one more thing I want to show you before before we take off. Switch this bright field to maybe like GFP or DAPI.
Which one do you think is better?
Neither. So either is fine. Or textbooks. So right now we have this montage set up. Right? We don't want a montage right now. So go to imaging mode.
So just spot me image
And,
for you.
yep, and uncheck the montage. And then we want a Z stack, right? So we want to go to Z stack option and then go a couple steps from this course height.
Yeah?
Yep, go a couple steps above, maybe one more. And then set the Z top. And do the same on the other side for the bottom. Yep,
Like here?
yep. And then capture this image, which is this. Alright, so this is the 3D viewer. It's gonna look really terrible. Click OK.
No. Okay, I got it.
Understood. So did you do this for the bright field as well though?
It doesn't
My
happen
son
on
is-
bright field. You can do that on bright field.
Oh, okay.
Because the way bright field like the light, this is only works. This actually only works in a dark light.
So what is this, if this doesn't work for fluorescent or bright field, what is this intended, what's the intended use?
I said the
Just to
organoids.
have fun with it and just look at your 3D samples. It doesn't serve any purpose though. Like if you want to, maybe export, the 3D rendering of your spheroid, then it makes more sense, right? Because you would have a true 3D sample. But honestly, our software is not very well designed for that. You can actually just use an image chain slightly better than what we have here.
Okay.
Is it designed for tissue slices? Or
It's just
histology?
it exists, but it doesn't. Let me say it differently. We have not updated this since a very long time, so it's not
Okay.
perfect. Yeah.
3D.
Oh, what?
Particular prison.
That's insane.
Yeah, but it's not the best for microglia, probably.
No.
No, I mean this would look like exactly like this even if you do it elsewhere because this is just a 2D sample.
Yeah.
But when you have a 3D sample, you'll have some 3D data to look at.
Okay.
My lungs
So
are
even
so
if
itchy.
the cells are actually 3D because they're cell, right? There's not like
Though, I mean, if
It's
you look
not
at the
the-
height, you know, those are gonna be like what, 5 microns, 10
yeah, it's
microns,
not- yeah.
not beyond that, right? So
Yeah.
it's not enough resolution. Alright?
Yeah, thank you.
Perfect.
That's so fun.
Chase, do you wanna open up one of your protocols? I can show you the beacon. Or you can also, I mean, is it
Are
okay
you
if she
okay?
does it?
No, you
Okay. I'll just show that.
Just guide
to
me
you.
because I don't
Yeah.
know. Can I close
Yeah, you
everything?
can close everything. Absolutely.
Yeah?
Yeah.
I'm gonna need to save it.
No, it's fine.
Okay.
Right, open up Gen file again. And then we'll just open up one of the protocols we have. Let's use the third one,
Organizer.
the one next to it. Actually, just click on open. Let's use the 20x one for now. 20x, yeah. Because so if you go then to the procedure,
Mm-hmm.
and then imaging steps, the second one.
Double
click.
click.
So now we are just collecting one image in this whole well, right? Every well is just one data point. So we can actually expand it because we have so much room for like taking more images and we get like more ends, so the data will be more reliable also. How do you do? There are like two ways to do it. One
Mhm.
is just to simply take a montage. So
Okay.
this is a stitched image. This is a 2x2 image. You can also expand this to like 4x4 or 5x5. And you know,
I
it's
can
gonna
cover
have,
the entire.
yeah, and you
Oh.
could, if you click on entire well, then it will also cover entire. You see this?
That's like entire.
This overshooting because you're taking 121 images per channel, so you're collecting 500 images just for one well. Multiply that by, you know, 8 megabytes of file size and then by 96, it's just too much data, right? We don't want that. So uncheck the montage. What my preference is for these assays is you can define beacons and click on the microscope.
Oh yeah, also what's the autofocus binning?
I can explain that to you in a second. Click OK. That's a great question. That's just to make your acquisition and everything faster. It's gonna bin like 2x2 grid pixels into one. So imagine your picture is made of 100 pixels. Right? There are like 100 pixels in this picture. Instead of taking 100 pixels, it's going to multiply those 2x2 pixels, and now it's going to only collect 25 big pixels. So the resolution is going to go down because it's kind of compiling all the information into one pixel that existed in 4 pixels, now it's part of 1 pixel. So you have much, like not much, but you have relatively less resolution, but it also speeds up the thing because it doesn't need to gather that much information. So it's going to deplete, like, you know, deplete the image quality slightly, but give you much faster data, and the file size are going to be smaller. So basically, people use that in a high throughput environment to make everything faster. That's the only purpose.
That to adjust.
Yeah. So by default, it always uses the regular autofocus until you define the laser autofocus. Yeah. So.
So I do the circle out of focus, or the exposure out of focus.
Yeah, so right now, if you remember, we're just in the binning section, right? We are just applying binning. So it doesn't really matter. If you just want to click here, this is one field of view that you can, now you're going to image. So now if you just click anywhere within the well, yeah, maybe go a little bit further down and then set up like one arrow there. You have another region of interest here. So now you're going to have 2 regions of interest in this well. And then you can go to the next well.
Like here.
Yeah, sure. And then you can apply it here. So this is one way of applying binning, but this is not really practical because you just want, you know, more field of views. So I would just remove all the beacons in the vessel I just wanted to show this option existed. So if someone has like, like your samples, if you are interested in something that's very specific to you, you can just define those beacons, and it's then going to go and image all those images for you.
Overlooks.
Yep, and then you can create a grid from here. So now we have 9 data points for this image. And then if you click on A2, you only see B for this well because we didn't set it up in any other wells, right? So now we can click OK and copy beacons in all the wells in the vessel. And yes. Now everything should be applied to all the wells, and then we see the settings. And let's just try it in like 2 wells, that's it. So click on this guy, clear all. Maybe just select like 2 wells.
What it will be right now.
Everything B is like, it has beacons on it.
Is it again B2, B3?
And yeah, click OK.
So we don't need to focus do the
So it's
focus?
already part of the protocol, so
Oh.
we don't really need to set that. So to go back to your question, if you came back from the manual mode to the experiment mode and you want to apply the laser autofocus, you would have to go to this focus options tab and select the laser autofocus from, uncheck the default, select the laser autofocus, and then it will take you back to the manual mode to just find, train the software for whatever find for the focus. Click OK and you will see something like this. Click OK, sorry. Click OK one more time, and OK one more time, and start. And sure, let's just see what changes. He doesn't really need the 20x.
Oh, it's gonna.
That's fine. He's gonna probably use the 10x, but this is just to showcase.
Should I add something like test or something? So I don't mess up with this protocol?
We already changed the protocol, but this is something I made, so it's not really what he uses.
Oh,
And if you wanted to retrieve those protocols, you just go to the experiment
Yeah.
and then go to file and save protocol as. Yep.
So it's, the beacon's going to take an image from the same spot of the well for each well.
Mhm.
Fine.
Those languages.
Yeah.
We can even combine beacons with montage. So if you want to do like a 4x4 in those 9 locations, you also check on the montage. So if in case you go to like higher magnification,
Uh-huh.
You can then select 9 spots, but also as a 2x2 montage. So then it goes to those 9 locations and do the montage, and then it also applies these stacks. You can do all sort of stuff.
So
with
they
it.
can, all the functionalities can be layered on top of each other.
The data set is going to get
It's
larger.
going to be huge.
Yeah, so after maybe like tomorrow or something, I'll send you guys a link for so if you found this training useful or not, just let us know your
Sure.
feedback, so that'll be very helpful for
are you gonna leave the recording here?
Yeah,
on the
everything is
computer?
gonna be local, so if you just go to the Windows Explorer and then go to the videos, you would see all the videos right there.
Okay.
All the screen recordings are right there. Oh, actually, I have it. I was just testing if this works or not. If you have your smartphones, you can scan it. It's just gonna take you a couple minutes. You don't necessarily need to do it. It's anonymous, so your names we would not be able to see your name. So if you not do that, I'm just gonna leave my phone here.
Yeah.
It's completely optional.
Yeah, it's also open the thing to do it later.
Oops, it's almost at the end. So now this is how you would see the beacons options. So you see all the 9 FOVs. You can go into any of them once the homing is done and look at the the morphology and all the channels and everything. So it's quite nice. Give you much more data to work with. And you can also see all of them together. And once you populate some results, like if we have some results here, like cell count, you also see like the total cell count, but you also see everything like per FOV,
Oh, okay.
which is quite nice. So if you have something that doesn't make sense, you can also like mark it as an outlier and just eliminate that from the calculation. Also,
It's pretty cool.
yeah. Awesome. Any outstanding questions before we conclude today's session? I know we covered a lot. So
Oh, can we just put that function in the protocol, the primary, secondary mass definition?
you wanna set up a protocol with
Just
what we
modify
have
the existing
right now?
protocol.
Okay, sure. Do you wanna take control so
Yeah.
I can walk it through? Sure. Maybe it would be nice to look at some image set and then
Yeah,
just set
yeah.
it up there.
Can I just close out of this?
Yeah, please go ahead.
Why not? Just a test. Let's see.
You guys have a trash here?
Oh, the camera, sorry.
Oh, no problem. I just didn't see it.
I think out there somewhere. Oh, if you turn right, I think, and then there's a little cubby on the left. Let's- Oh, wait. Oh, wait, no, let's do. that one. Oh, wait, but it'd have to be set up. Actually, we'll see.
You can save it as a protocol.
Okay.
Yeah, yeah. So you wanna start off from the nuclei, right? As a
Mhm.
primary mass and go from there. Okay, let's do it. So let's just go to any of your images first, and then yeah. So we have a lot of analysis already applied. So which one do you think is not really relevant? Then we can just delete that. So it's gonna save you some file size, because otherwise it's gonna keep everything in the protocol.
Probably the DAPI statistics. Probably the GFP statistics too.
And then you want to keep the circularity because of
Yeah.
GFP. All right, yeah. So we can go to the calculator step, which is that one next to it, and then delete that from the statistics. Right click and remove. Yep. All right, and then click OK. Do you think the pre-processing might help the results, or do you wanna skip out?
Yeah, let's do it. Why not?
Sure. So, yeah, apply that pre-processing. Double click.
Oh yeah, what's this deconvolution?
It's only good for like very high magnification, is like 20, 40x
Uh-huh.
images. You know, this is a wide field system, so it will have its imperfections, right? So
Mhm.
this is just a digital algorithm to sharpen the image, and it's
Mm.
going to basically apply some pixel smoothing and blurring depending on how your image looks.
Okay.
It's also very commonly used on ImageJ. So this is just a much more refined version of that here. So it's just the pre-built, but you don't really need that for what you're doing.
Okay.
If you go to like 40, 60x, then you might be able to use that nicely. And then we want to apply the same processing for DAPI and GFP, but not for the phase and the
Yeah.
other one.
This is a 20, right?
So that's a great point. So here, this is actually
Oh, it's gonna
changing
be-
and
yeah.
affecting the global image. So if you set it up to be 20, it's gonna try to erase something that's above the file size of like 20 microns or object size of 20 microns.
Oh.
So the other one is not gonna erase any information. So there we can be more restrictive. Here, we have to select it at least 3 times the size of your object.
Okay.
So if you want to apply this very precisely, then you can set it up to be like 60 or 70 microns.
Yeah, let's do 70. I think
Sure.
they kind of get big.
Yeah, and then for DAPI, we can maybe set it up to be 50 or 60 because the nuclei should not be as big. And then phase, we want to skip the background flattening, so yeah. Yep. Same. Perfect. Click OK. And add step, which will add the step to the workflow. Let's see how long this takes. Not so bad, I think. It's fine. Okay. So now we can go to maybe, once this is done, we can go inside this image and set up. So go to analyze option. We haven't set any analysis in that, so click OK. And then we want to run a cellular analysis on the DAPI first because DAPI is going to be the primary mask. So uncheck everything else, keep the DAPI on. Alright, then just go to the options. Now the max size we know should not exceed like 40 microns for the nuclei, so you can select that for the maximum size. The threshold we don't know yet, and the advanced options we know like it's close to like 15-20 microns, right? So we can just go to advanced and set it up to be 20 microns for the ruling one. Yep, click OK. And one more time, OK. That's pretty good.
Is that an issue, or do you think it's?
Yeah, we can try to resolve that. So if you scroll up and zoom in there, draw a line profile tool across like maybe these two cells. So yeah.
And there's that.
This and this would be easier, I think. Yeah. Okay. So now we see two peaks, and that's 25% is 142, 14,000 basically. So you can go to the options tab, set it up at 14,000 for now. Click OK.
There we go.
So those are good, but let's also look at the whole image to see if we missed something. It's perfect. So that's great.
Yeah.
So now we want to apply the secondary mask on GFP. So we go back to options, secondary mask, GFP. We don't want to identify something inside it, right? We want to expand the primary mask. So uncheck the first
visual.
tab, and the second one stays on. Yep, expanded. 50 microns is my go-to number, and then you can increase that or decrease that. I also just use the random auto threshold for now. And I apply like a couple, actually that's fine, 5000 is fine on the default version. And then we can change that accordingly. And then I apply like 2 or 3 cycles of smoothing to make it even. Otherwise it's going to look very funny. Yep. So, click OK. And now let's look at the GFP image. So if you toggle the GFP on, uncheck the DAPI. Go to GFP. And check the secondary mask on, and uncheck the DAPI so it's easier for us. Maybe increase the brightness all the way also on the top section. So we are missing out, here, all of that.
Mm-hmm.
So now we can decrease the threshold. So we can go back to the options, and maybe decrease it to 2000 for now, and see if that works. Because we are also gonna get a lot of non-specific information.
Yeah.
If we go below that, we can try. I mean, we can see how much background is, and we have to at least keep it higher than the background value for the
Mhm.
GFP. So how do you find the background? Is you would just use this line profile tool and just draw it across the whole image, and the background is like 770.
Mhm.
So maybe you can set it to 1000 and see how that works. It's a little better, right?
Yeah. Yeah, it's doing a better job capturing it. You can see it.
Mhm. And then you can keep on playing with the threshold until you are able to resolve between the background and the real signal. But we can't do it yet. We have to collect some images first to get an assessment. What works and what not. Oh, we have images, right? Yeah, we can add actually. Yeah, click OK. Maybe add a couple more image set. Yeah, and then add whatever you think would make sense.
It's
It's
pretty good.
yeah, it's pretty good. Okay, so I mean, if this works,
Let's do one.
yeah, let's do one more.
It's each the last card.
I don't know what that is. But if you go back to the DAPI, I don't think we're catching most of it. So we can kind of mark this image as an
Oh,
outlier.
that's
Yeah,
why.
that's why. So it focused on this, you see.
Yeah.
That's why. It's fine.
Conclude with that image. Any questions? Here's my survey.
Got some jump looks like a hair fell in or something.
Yeah.
Okay.
Yeah.
Yeah, there is also some like debris here, but it's absolutely fine. You're gonna have some locations like that, so it's fine.
Yeah. I just want to kind of see it. I almost
Yeah.
wonder if it actually. No, it is a debris. Yeah.
Yeah. Do you think this is good?
Mm-hmm.
Okay, perfect. So now then we can go to the options tab, calculated matrix, and then set everything to none first. Yeah, and then cell count so we can normalize the results. And then we want just the secondary mask information. And we don't want anything from the DAPI, right? So anything that is not _2 is for the primary mask. So we don't want that.
Everything that's not what's
Not _2
Oh, yeah, yeah.
is primary mask. So we don't want that. For the secondary mask, you can get some parameters here. But if you go to the select or
Yeah.
create, we can have some more, like length and width.
Yeah.
And then also there is a size. I don't know if the size is gonna help you or not. Yeah.
I can't remember. What's the calculation between size? I remember you said it's like weird.
There is some. I can find it out before I leave and show it to you. There's
Okay.
some mathematical equation that uses the length and the width and determines the size based off that.
Okay.
Yeah.
Is it correlated to area? I'm just like wondering.
I mean, yeah. If you use length and width and you know the shape of your object, then yeah, it should be correlated to the area. So
Okay.
yeah.
I just remember you said it wasn't area when I asked. So I was
It
like,
does. It's definitely not area.
Okay.
But you get the area here.
Okay.
You have the area here. _2 is that area.
Got it.
So now we can also remove the things that you don't really need. Yeah.
I just want to say hi and thank you. I have to
Oh,
go.
yeah. You're most
Thank you
welcome.
so much.
Yeah, take care. Yeah,
Very
thank
nice to
you.
meet you. Yes. Good luck.
Bye, guys.
See ya. Why is there 2 areas?
There's phase contrast. Everything is phase and bright field, so you
Yeah.
can, yeah. Yep. And the first area is for the nuclei, and the size is for the nuclei.
Yeah. Okay.
Yep. Yep.
Okay.
And then if you wanted to generate your own parameter from that, let me just show that to you. Go back.
Oh, yes.
Yeah, go back to that. Select or create, insert custom metric, and you can use your length and width over there. So the length is, the secondary mask. Yep.
I'm assuming it's always going to make the length bigger than the width, right?
Yeah, the longest axis is
Yeah.
that. Yeah. And then you can give it a name.
There's a specific name for that metric, do you
Aspect
remember?
ratio.
Aspect
Aspect
ratio.
ratio.
What is this well operator?
Yeah, so it's going to give you, if you look at the image level results, that's the only place it would change. So if you take the mean, then it's going to take all the numbers and then
Mhm.
give you a mean here.
Mhm.
If you take like the sum, then it will just sum it up
Oh,
for
I
you
see.
and
These
stuff
are-
like
okay,
that.
I
We
see.
typically stick to the mean.
I see, yeah, you can just define different metrics that
Yeah.
shows you at the
Image
image
level
level.
results. Yeah. There are a lot of them that are. Oh, this is
I
just
think
an
it's
app though.
yeah.
Yeah, I mean it's not terrible. Could be better. Like this,
Mhm.
this, but I mean it's still good for what we are getting
Yeah.
so
That's what
far.
the mirror is for.
And this is the aspect ratio and the length and the width.
Cool.
Yeah. So you can maybe also just use your length and assume that the longer length is the one that's
Yeah.
trusting.
Yep, and there it is per individual cell.
Yeah. And then you also get that for like the area, the whole area. So I mean, I don't know if the area is gonna change because even the circle ones are gonna be somewhat similar in nature.
exactly.
I don't know.
I think I did look at area before and I didn't really see a signal there. So,
Yeah.
and then,
Can we try just one quick thing? If we go to options for the secondary mask, let's do like 700 and just hit up 700 and hit apply. Don't hit OK. Let's see what it does. It's not that bad, when you look at it.
yes.
It's decent.
Mhm.
How about 500? Just trying to push it. So
Yeah.
it's,
Until eventually it starts creating blocks.
yeah, exactly. Okay, I mean, it's acceptable.
Yeah.
If you look at these images, is that still the same? Not the same. Yeah, I think this is still pretty good.
Yeah.
And it's catching more information.
Mm-hmm. Actually capturing it very well.
So yeah, once you're satisfied with that, then you just add step, and that will add the step to the workflow. And again, you can go back to the subpopulations and try to create different groups if you think you wanna create different groups between like circular cells and elongated cells. You can also create groups there, and so a lot of options. And then you can close this tab, and then you can save this as a protocol for now, so you don't miss it.
Yeah.
And then in that protocol, you can further add beacons if you would like, or something else. Yeah.
Okay.
Do we see any trends? I'm just curious. That's good.
Yeah, not too much.
Really. Yeah. we have the circularity there, or no? Yeah.
Yeah.
Circularity, but this for
Yeah.
GFP. Yeah. It's unfortunate that we can't populate that for like secondary mask. Otherwise, that's all you need.
Yeah. Exactly.
Literally. Yeah.
But no, that's still cool to know and know how to do. It might be useful for other metrics.
Yeah.
I know it's programmed in there. Knows that.
Mhm.
Figure it out.
Perfect. And you feel confident about setting up the beacons yourself if you need to?
Yeah,
Or-
yeah.
Okay. Perfect. Awesome.
I think I'm all good.
Right. Any outstanding questions? Last word questions.
Yeah, maybe you can just send an email anytime.
Yeah, yeah. Once you start using it, you have a
Yeah,
lot of
yeah.
questions. So reach out.
Yeah, sure.
Happy to help you. All right. Perfect.
You told me to remind you for your plate. Did you grab that already?
Yes, thank you.
Okay.
Thank you so much.